Jai Hind everyone. Today we are going to start data analytics life cycle in the subject data analytics. So we need to understand what the data analytics life cycle is. We see data science projects differ from the business intelligence projects. In the previous lectures, we have seen how data science and the business intelligence, these terminologies are differ, where they differentiate what is the difference in between both of them. So we have seen data science is more towards exploratory instead of explanatory, where the BI comes in, right? BI follows explanatory approach, or you can say more towards explanatory, where the approach is being used. And in the case of data science, it is more exploratory in nature, right? The data science project is critical to have a project process. Participants should be thorough and rigorous. It is not like they are not having the rigorous information of the domain and then they can do. No, it's not like that. For the data science projects, the data scientist must be the highly technical persons, right? And they are which are having the complete understanding of that particular domain. Break large projects into the smaller pieces, spend time to plan and scope the work. Documenting adds rigorous and credibility. So we can see the data analytics life cycle. This includes 6 important and the major phases, which says number 1 is discovery, phase 1 discovery. Then we will be working on the data preparation. Next we have model planning, model building, communicate results and operationalize. These are the major 6 phases of data analytics life cycle. The discovery says what we are going to do. We need to understand what the problem is, what the solution we are going to provide. Whether it is a problem for that the solution is already existing. If the solution is already existing, then why we are here? What we are working with this problem? What new we are going to include in the solution, right? In case if the solution already exists, what is the drawback? What are the loopholes? What improvement we could do, right? We need to understand. Then we come towards the data preparation. Data preparation, the very important phase of the data analytics life cycle. Why it is so? Because approximately 50% efforts we need to do at this phase only, right? We need to collect the data, we need to clean the data, we need to condition the data, we need to normalize that, and so forth. The complete process we need to do when we say data preparation, right? That's why we are saying approximately 50% of the time it takes. Then model planning, we will be working on the planning of the model, then model building, communicating results, and finally operationalization. So the data analytics life cycle is designed for big data problems and data science projects, right? When we are having a huge amount of data, or we can say the size of the data is too much large, there we are using this. With the 6 phases, the project work can occur in several phases simultaneously. The cycle is iterative to portray a real project. It is not like once I have jumped to the another phase, or I have completed one phase and I have entered to the another phase, I cannot go back. No. It's not like that. Yes, it is a iterative process. Iteratively, we will be working. Work can return to earlier phases as new information is uncovered. That is the thing I was talking about. It is not like that we cannot go back. It is an iterative process. Once I'm getting a new information or some other information has been uncovered, then I can go back. So here we see key roles for a successful analytics projects. What are the role players? Obviously, number one, business users. Then project sponsor, project manager, business intelligence analyst, database administrator, the DBAs, data engineers, and the most important one, data scientist. Now we'll see what are the roles of these key roles over here in the data science project. Business user understands the domain area, what the domain is. Maybe you are working on a financial sector, maybe you are working on a healthcare sector, and so on. Accordingly, business user needs to understand the domain area, right? Project sponsor, which provides the requirements. Project manager ensures meeting objectives. Then business intelligence analyst, it provides business domain expertise based on deep understanding of the data, right? DBAs, the database administrators, creates database environment, right? Data engineers provides technical skills, assist data management and extraction of data, how to extract the data, and support analytic sandboxing. And finally, we have data scientists, which plays the most important role, which provides analytic techniques and modeling, right? So the background and the overview of the data analytics lifecycle, if I talk about it, includes, it defines the analytics process and best practices from discovery to project completion. That means from first phase to the final phase, right, till the end of the project. So this is the overview of the data analytics life cycle. What we have seen, number one, discovery. What does it mean? Do I have enough information to draft an analytic plan and share the peer review? Number two, data preparation. Do I have enough good quality data to start building the model? If not, I need to work on the data preparation. Then model planning. Okay, do I have a good idea about the type of model to try? Can I refine the analytic plan, and so on? All these things needs to be rectified over here only in the planning phase only. Once it is done, then we'll move towards the model building. What model I'm going to build, which I have decided in the planning phase. If it is working, if it is going towards the right direction for which I have planned, then further communicate results. When I'm saying communicate results, is the model robust enough? Have we failed? For sure. Are we I'm going to a success for sure, and so on. Accordingly, we need to communicate the results with the other users, whosoever are the user. I need to communicate to my stakeholders whether this project is going to be a great success or going to be a failure, right? So whosoever the users are, I need to communicate with all those users, right? And then operationalize. If all goes well, then the model will be operationalized. So I'll be discussing one by one each and every phase. So we'll be starting with the obvious, the phase number one, that is discovery. So in case of discovery, learning the business domain, the prime most thing, the most important one. First of all, I need to understand the business domain. Then resources. Resources could be anything. It includes every user, it includes data, it includes content and so on. How it is so? Resources. Identifying the key stakeholders. That is also a resource who are going to be a stakeholder in my project. Who are going to be the analytics sponsors, right? Then what are the data sources? From where I am going to collect the data? What are the potential data sources from where I can collect the data, I can acquire the data? Then only I will be able to do working, or I will be able to work on the second phase, that is data preparation, right? So it becomes too much important to understand. Fine. Second, resources. Okay. Next, framing the problem. Again, a big challenge. What I am going to do? What the problem is? If the solution already existing, then what else we are going to do? Why we are here? If it is not there, then what we can do? What solution is the solution which I am proposing, or we are going to solve in the manner? Is it a feasible solution? How much useful it is, and so on, right? I need to frame the problem. Then after discovery, we enter to the second phase, that is a data preparation, and for which I have told you that approximately 50% effort is going to be done over here only. So what we are doing here, it says data preparation says includes steps to explore, pre-process and condition the data. Exploration, we need to explore the data. Data needs to be pre-processed, but obvious. Now the third term, that is condition the data. What does it mean by this? Sometimes, for example, we measure a distance, say in meters, say in centimeters, maybe in meters, maybe in some of the data is there, that is where I have used a kilometers, right? So how I can perform any operation on the data when the measurement units I am considering, these are different? So I need to come on a common pitch, right? So that is conditioning of a data. I need to normalize my data, create robust environment, analytics, sandboxing. Data preparation tends to be the most labor intensive step in the analytics life cycle, right? Often at least 50% of the data science project's time it takes. The data preparation phase is generally the most iterative and the one that teams tend to underestimate most often. But this is the most important phase of the data analytics life cycle, because if the data is not correct, if the data is not accurate, then we cannot get the good values. It cannot create the good results. So we'll see what is the preparation, what does it mean by preparing a analytics sandboxing, which we have seen in the last slide. Create the analytic sandboxing, which is also called as a workspace. What is this workspace? Allows team to explore data without interfering with live production of data. It allows a workspace to work on the data before interfering onto the live data. Sandbox collects all kinds of data, that's why it is known as a very expensive approach, because it is collecting the data of all kinds, right? The sandbox allows organization to undertake ambitious projects beyond traditional data analysis and business intelligence projects to perform advanced predictive analytics, right? Although the concept of an analytics sandbox is relatively new, this concept has become acceptable to the data science teams and IT groups because it is a very useful concept. Performing ETLT. What is ETLT? Extract, transform, load, and then again transform. The ETL users perform extract, transform, and load. In the sandbox, the process is often ELT. Early load preserves the raw data which can be useful to examine. Right? For example, say we take the example of a credit card fraud detection. The outliers can represent high risk transactions that might be inadvertently filtered out or transformed before being actually loaded into the database, right? Learning about the data, it becomes familiar with the data is critical, right? How to become familiar when the data is critical? This activity accomplishes several goals. Number one, determines the data available to the team early in the projects, highlights the gaps, which identifies data not currently available. That means the data we require and it is not currently available, so it highlights the gap. The data is required but not available. Identifies data outside the organization that might be useful, right? Outside the organization. Sometimes we may require the data which is beyond the boundaries of the organization, but it is important for us as an organization person to include that data, maybe for the competitive advantage. Now we have another term, that is data conditioning. Data conditioning includes cleaning the data, normalizing data sets, and performing transformations. Often viewed as a pre-processing step prior to data analysis, it might be performed by data owner, IT department, DBAs, and so on, right? So it is best to have the data scientist involved. That means data conditioning or any kind of processing. If we are working on data, it is always advisable to include the IT professionals. Data science teams prefer more data than too little, right? So here we have some additional questions and considerations. What are the data sources? What are my target fields? How clean is the data? How consistent are the contents and the files? If some missing or inconsistent values are there, assess the consistency of the data types, either it is numeric, it is alphanumeric, and so on. Review the contents to ensure the data makes sense. Look for evidence of systematic errors as well. Next, we have survey and visualize. Leverage data visualization tool to gain an overview of the data. So here we have Chandraman's mantra: overview first, zoom and filter, then details on demand, right? So this enables the user to find areas of interest, zoom and filter to find more detailed information about the particular area, then find the detailed data in that area. Some guidelines and the considerations we have: review the data to ensure calculations which are consistent. Calculations are consistent. Does the data distribution stay consistent? Assess the granularity of the data, the range of values, and the level of aggregation of data. Does the data represent the population of interest? Check time related variables, like time related variables, that means maybe daily, maybe weekly, monthly, and so on, right? Is this good enough or we require something changed? Is the data standardized or the normalized? Scale consistent? For geospatial data sets, the state or the country abbreviation consistent or not. So these are the common tools which can be used for the data preparation, like Hadoop, Alpine Miner, OpenRefine, and Data Wrangler. After data preparation, the third one, that is a model planning. So here some of the activities to consider, these are: assess the structure of the data, which dictates the tools and analytic techniques for the next phase. It ensures the analytic techniques enables to team to meet the business objectives and accept or reject the working hypothesis. Determine if the situation warrants a single model or maybe a series of techniques, right, as a part of the larger analytic workflow. Research and understand how other analysts have approached this kind or a similar kind of problem. That means, what are the existing algorithms that has already been implemented and what is their performance? If X algorithm is giving me a better performance, then what is the use of using the another one, right? And if I'm using another algorithm, what is the performance metrics, right? So I need to check it out and accordingly will be decided. Data exploration and variable selection. Explore the data to understand the relationships among the variables to inform selection of the variables and methods. A common way to do this is to use data visualization tools. Often, stakeholders and the SMEs, the subject matter expertise, may have idea, for example, some hypotheses that lead to the project. The aim for capturing the most essential predictors and variables. When we say predictors, excuse me, we talk about the input variables, the most important input variables and the other variables, affecting variables. This often requires iterations and testing to identify key variables. If the team plans to run regression analysis, identify the candidate predictors and outcome variables of the model. That means simply I need to find out what are the input variables, what is the output variable I'm going to have, right? Accordingly, we will be deciding the dependent and the independent variables. Then the model selection. Main goal, right? The main goal is to choose an analytical technique or several candidates based on the end goal of the project. We observe events in the real world and attempt to construct models that emulate this behavior with a set of rules and some of the conditions. A model is simply an abstraction from reality only. It is not like that, it is not related to the reality. That is a virtual concept or something. No, it is an abstraction from reality. Determine whether to use techniques which are best suited for structured data, for the unstructured data, and could be a hybrid approach, right? The team moves to the model building phase once it has a good idea about the type of the model to try. That means once we are done with the model planning, we are clear which model we are going to use, which model we are going to build, then we move further towards model building. So here we have some of the common tools for the model planning phase, right? Either we could be using R or SQL analysis services, SAS or Access. R has a complete set of modeling capabilities which contains about 5,000 packages. Excuse me. SQL analysis services, it can perform in database and analytics of common data mining functions. SAS provides integration between SAS and the analytics sandbox via multiple data connections. After planning, now we move further towards a model building, right? So what it is doing, it is working on the model which has been decided or which has been planned in the phase 3, that is model planning. Execute the models defined in the phase 3, develop data sets for training, testing and production. Develop analytic model on the training data, test on the test data. Here we have some of the important questions that needs to be considered, that is, does the model appear valid and accurate on the test data? We are having two types of data. One is test data, second is train data. We need to use that. Does the model output or behavior make sense to the domain experts? Right? If it is working well, does it make any sense? The output, does it make any sense to the domain experts? Do the parameters, the values of the parameters make sense in the context of the domain? Is the model sufficiently accurate to meet the goal? Does the model avoid intolerable mistakes, and which is very important? If the mistakes are intolerable mistakes, model should not avoid that, right? Are more data or inputs required? Will the kind of model chosen support the runtime environment, or it is not able to handle that? Is a different form of the model required to address the business problem, or the model is able to solve those type of business problems for which I am preparing a model? So, what are the common tools that can be used for building phase? The commercial tools we are having, and some of the open source tools also available. So, commercial tools are there, that is SAS Enterprise Miner, SPSS Modeler by IBM, MATLAB, Alpine Miner and Statistica and Mathematica. While the open source tools which are available, that is R and PLR, Octave, Weka, Python and SQL. After model building, now we are ready to communicate the results. So, what does it mean? Determine if the team succeeded or failed in its objectives, whether it is a failure or a good success. Assess if the results are statistically significant and valid. If so, identify aspects of the results that present salient findings. Identify surprising results and those in line with the hypothesis. Communicate and document the key findings and major insights derived from the analysis. This is the most visible portion of the process to the outside stakeholders and the sponsors, right? The last phase, which includes operationalization. It is the last phase. The team communicates the benefits of the project more broadly and sets up a pilot project to deploy the work in a controlled way. The complete model is not gonna be deployed in a single go or at once. Initially, a pilot project will be setting up, right? Risk is managed effectively by understanding small scope pilot deployment before a wide scale rollout. During the pilot project, the team may need to execute the algorithms more efficiently in a database rather than in-memory tools like R, especially with the larger data sets. To test the model in a live setting, consider running the model in the production environment for a discrete set of products or a single line of business. Monitor model accuracy and retrain the model if it is required, or we say if it is necessary. Fine. So, these are the key outputs from successful analytics projects. The key outputs from a successful analytic projects, this yellow one that shows the code, and here we have some of the presentations for analysts, the technical specs, the presentation for the project sponsors and so on. So, all the users are ready with their outputs of the model. The key outputs: the business user tries to determine business benefits and the implication. Project sponsor wants business impact, risk, ROI. Project manager needs to determine if the project completed on time, within the budget, whether the goals were met or not. Business intelligence analyst, BI analyst, needs to know if reports and the dashboards will be impacted and there is a need to change. Data engineers and the DBA must share code and documents as per the agreement, right? Data scientists must share code and explain model to peers, managers, stakeholders, and so on. These are the 4 main deliverables: presentation for the project sponsors, presentation for the analyst, code for the technical people, and technical specification of implementing the tools. So that's all about the data analytics life cycle. Here these are the references from where I have included the content in my slides.